Good morning. Hello, all my little star children. Hope we're doing okay. Hope you're feeling great today. This morning is all about manifesting our intentions and setting our goals. Right now, I would like you to begin the inward journey into your mind palace. Your mind palace, of course, is where we set the namaste for our emotional sunrise and sunset that will take us on a journey. Let's begin with some box breathing. 4 seconds in. 4-second hold. 4 seconds out. Hold for 4 seconds. We're doing wonderfully. All right, my star seeds, my wonderful little lotus blossoms. Today in this...
Hey, who are you?
I'm in the wrong class. My apologies to all. Namaste.
Gosh, Pittman taking over my class. Pittman just taking over my class. Oh my gosh, you got it. You never know where Pittman's gonna show up. Everyone knew the first time we did this. Okay, I will admit that is a pre-recorded video. People are asking in the chat. And he wanted me to send this to him, so I'll tell him there's a live video now. Shout outs to Pittman. So who thinks we should boo? Should we have Pittman come back this semester and do another guest appearance if he's free? Should I try to steal him away? Oh no, Zariah's throwing tomatoes at us. Should we? And I wanted it to do it here that way because this is where people can see it. Had me fooled. Nice job, Zariah. Okay. I could restart the video here, and I cut it from a year ago now, actually. If you don't know Matthew Pittman, shout outs Pittman. Does anyone want to drop Pittman's channel in the chat? If you want, drop Pittman's his socials. I should be able to find it maybe, or UT doesn't have, but it's UT. Let me see here, Pittman. I should have it. Here is Matthew Pittman, and then we should be able to find his socials and stuff. We could drop it here. There is Matthew Pittman. He grew his hair out. It is shorter again, I believe, right now. And he has the social media center. Let's see here. Social media UTK Pittman. He makes a lot of the fun videos. So social media influencer. He does so much cool stuff. And I don't know why there's not links to his social media on here. But is anyone gonna drop it for us right here? I want to go find it. I should have it. He is very strong. I need to up my game. So Brian stopped lifting after he hurt himself. Here's his Instagram. Okay, here's Pittman's Instagram. There's Pittman's Instagram. So go if you want Insta. If anyone wants to drop, I think I can't get to TikTok here. So there's Pittman's Instagram right here. He does a lot of the funny videos. You see, look, 1.8 million views right there. That is crazy. Yeah, I actually had a leg day when I went down my stairs at home, and he is so funny and so nice. So I emailed him randomly over winter break 2024 and was like, hey, I teach at UT, you teach at UT, and you do kind of internet stuff. I do internet stuff. I said it in a different way than this. I was like, you want to come to my class and do something? And he was like, yeah, let's do it. And he was like, that sounds awesome. And I don't know if I had met him before he came to my video. I don't know if I've seen that one, Zariah, but add his Insta right here, add his TikTok, check it out. I mean, look at that. 1.8 million hearts, 12,000 comments. I mean, that is doing really good right there. That one didn't get that much love. I think this is the "You Shall Not Pass" video at the dinner table. Oh, now I got to go see this. But if you haven't, has anyone subscribed to Pittman right here? I wonder if I click on it now if it'll go up. Let's see. Can we make this go up to 99.3? I don't think we have enough people here right now. That'd be pretty crazy if we saw that go up by we went 99.3. But he puts out amazing content. And also I've heard, has anyone taken Pittman's class? Then we'll go over and do some work after this. Who's taken Pittman's class? Because I hear students, when I went to his class, every class has its own fear. I was like, I have never been in a class like this. It was very interesting, fun, engaging. Not that other classes aren't, but I was like, this is something. It was an experience. And so definitely check out his classes. They probably fill up like, I bet you, yeah, it's probably like, used to have a class called History of Rock. I think it might still be here, but back when like there was a teacher, what he teaches, well, we should pull it up right here. Does it not have the classes he teaches? Is that his website? Let me look here. He teaches like a social media class, and it doesn't have which classes he teaches here. He teaches like a social media class. So hopefully I'm saying that right, but truthfully, take any class you have with him. He also, I know he helps out a lot of students. Yeah, there you go, Sean. There you go, Sean. History of Rock. It might be different teachers than when I was here, but it used to be that was the big class everyone wanted to take. So shouts still History of Rock here at UTK. And also I will mention one last teacher, and then we're going to do some office hours. But I think I mentioned him before. So one last shout out to Tori Olson. So Tori Olson, another great educator we have here at UTK, across all different departments. You guys know I'm Haslam, but we shout out everyone from all across UTK. We actually have this book, Red Dead History, a video game, an obsession in America's violent past. But there it is, Red Dead History right there. I have that book, and it's signed by him. And here is it's going to show a bunch of, I don't know what they're going to ads to us. But Tori Olson, really great educator here at UTK. And I told him I was going to swing by his class because currently the Grand Theft Auto class is going on. I got to check out the times it's being taught. I think I saw it lines up with where I can swing by. But that's what we got going on. Who wants to do some work? Who's here for some Chapter 7 now?
Let him cook now. Let him cook. I said.
Oh, that's how I do that. Oh, we're morbing in. That's how I do that. Interesting. Chapter 7. Anybody? Properties. Fixing the video. What it was is I had the video, like I stole the video and then I used it on this screen. What questions do people have? Ooh. Put a little chill music. Day before spring break. Do some Chapter 8 quiz. Anyone here? Bueller? Do you see anything big happening right now? Looking at some quick emails to make sure nothing's on fire. Don't see anything too bad going on. Nothing too crazy. Questions? We're gonna do a little more Pearson. Has everyone done all the quizzes? It's right before spring break. Everyone did it all? We have good work done. Who's still here? Zariah, Skylar, Charles, Dean. Everyone said Pittman's out. I'm out. Procrastinate. Well, do you want to do it? Get it done? I know what it's like. Last night I came home and I had 60 emails and I got it down to 30 and then I said, I'm going to bed. I actually passed out with my computer next to me. I was maybe shouldn't do work like just laying there in bed being like, put my computer next to me, and then I like put on a video and I was like, and I was like, I got up at like 1 a.m. and I was like, I didn't brush my teeth. I brush my teeth every night unless I pass out randomly while I'm doing work. Then I get up and be like, I had my contacts still in, but I have over 4,000 in my personal email. Oh my gosh. Figure out what to do with that 4,000 right there. It's over. It's a lot. So, assignment manager. Should we do Chapter 7? We've done a lot of Chapter 7. It's a lot of work. Take some time to relax this spring break, as we all know. I'm going to get some work done and relax. I need to start a new video game. Play too much Night Rain. I know you can say never play too much Night Rain. I don't know. I've already beat the game. Points. game a few times. Okay, I'm getting the screen oriented so we can. What was that? Okay, let's go over here to the main screen and do some questions. Here we go. Yeah, exactly. So here is the first question on the screen for us to do. We've got everything saved right there. Pulling up the office hours. And 11:23. Okay. And this is chapter 7 quiz. We're not doing chapter 8 right now. Chapter 7 quiz. And this is the correlation. So a good thing to know right here is, what is correlation? Correlation is the value of R telling us the strength, direction, and unusual features of linear relationships. Unusual features like outliers can drastically impact it. So the correlation between a car's size and its fuel economy is negative 0.726. What that tells you is it has to be a relationship that goes downward. You don't know it's linear, but it's moderately strong. Now, what do I mean by this is, if it's towards 0.25, we'd call this weak. And the negative doesn't matter. That's just positive or negative. 0.5 we usually call moderate, and there's no you have to call it this. I just like to. 0.75 is where I usually say strong, and 1 is perfect. And 0 would be none. There is no correlation. So you can see this is like a moderate strong. And this subjective, these words are subjective. But the closer it is to 1 or negative 1, the stronger it is. As in, these could all be negative, and you would still say they're weak, moderate, strong, or perfect. And perfect may be the only one that you can't dispute, because if it's 1, it's perfect, all the points are on the line. So now, when we look at this right here, what is the fraction of variability? Now, this sounds like a complicated question. But the fraction of variability is R squared, which is simply R squared. So all you have to do right here is take R and square it. You don't even have to type the negative, because you're going to square it away. And then you times by 100 to turn it into a percent. And that'll do it. So R squared is the percent of variability in Y explained by the variability in X. And that's got that answer. There we go. Let's see if we got other big ones, quick ones here. It's another R squared question. So how's everyone doing? You can drop a question in the chat if you want. Just be like, hey, wait, I got this question. Let's see here. Be like, wait, do my question. And this one is 1333. And this one is a random sample. Okay. So this one is once again an R squared question. They just give us the R squared. And Mubot, who might still be awake in the chat, hopefully. Oh, I didn't throw the 50,000 points. I owe you guys that. Remember I said I was going to throw a bunch of points? No one was like, where's our 50,000? I guess everyone had some fun. I'll do it right now if you're here. If you've hung out and you talked within the recent time frame, you do get the 50,000. The bookstore one, you want to do the bookstore one? We've done it a few times, but you're here. We'll do what you ask. This one, a random sample. We just talk about the percent of variability in Y, explained by the variability in X. R squared basically measures how well our line does. As in, this has an R squared of something like 53% we found, but this one has a higher R squared, I think, so the points are going to be tighter around the line. So this would be an even better R squared, so this is better. And a worse R squared would be something that explains less of the variability. The variability can be seen as how tight the points are. There's less variability unexplained. There's more variability not explained here. Birth rates, we can do birth rates too. So this would be 61.7% of the variability in price can be explained by size. I hate the way they phrase this because you have to reverse it. A linear model on size explains this percent of the variability in price. And there's only two answers because these are the only R squareds. And you just use that and you should get it right. Let's do the birth rates. Is it this one right here? Lillian, let me know if it's this one, then we can do bookstore next. Is it this question right here? This is one of the trickiest ones. So is this one? Okay, let me mark it in the thing, and then we'll do bookstore next. And this is the table shows birth rates. Okay. And okay. So what do you need to make solving this question a lot easier? What is going to make solving this question way easier? Solving this question will be way easier if you go and get what right now? Solving this question will be way easier if you go and get what? Which will do things that you don't need to do on the test. Like the things it does for you, most of them, like solving for the slope and intercept, are things you don't need to do on the test. The thing you need to get right now is the regression solver. The regression solver can be found under modules. So scroll down here on the modules to chapter 7, Regression Solver Pro, 9000. And click here, and then download the Regression Solver Pro, and then open it up on your computer. So this allows you to enter in the summary statistics or the data. You can enter in either, and it'll solve the values for you. So here's the Regression Solver Pro. Up top, you'll see where you enter summary statistics like the value of correlation, the standard deviation, the mean of x, the mean of y, the standard deviation of y, the standard deviation of x, or you can enter the data over here on the side. You don't have to enter it in on both sides. You only have to use one of them to solve. And it'll give you values like the intercept, the slope, and also you can use down here to predict, like plugging in values of x. You can see here it's already solved for you. That's why I didn't make these yellow, because it already solved for you the intercept, the slope. And once again, you can plug in values and it'll solve it out for you. So that would be B0 and B1 respectively. We'll rewind time right here. And now we'll go and grab our data for this question. So for this question, you are given the live birth rates from the year 1965 to the year 2015 in 5-year intervals. Now first, before we use the regression solver, what is the trend in this? Is the birth rate going up, down, or what? Does it go up and down? I ask this because if you look at the graphics, this is the birth rate going up, this is the birth rate going down, with a little bit of random variability. This is it going up, then down, and this is completely... That last graphic's random. It's just a random, like it's random. It goes down, up, down, up, down, up, down, up, down. That's random. So what does it look like the birth rate is doing? Does it? Well, let's see. Good question. Let's throw some 5,000 points to that answer. Let's see what the birth rate does. So we'll go right here. It goes down. Well, we'll go between this. Down, down, up, down, up, down, 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 down. We're talking between. The last one, well, right here, you notice it in good answers, it goes down right there. And there's only 2 ups. Do you see there's only 2 ups. Between here and here, it goes up. And between here and here, it goes up. Because 15.62 to 16.39. So which of these graphics, A, B, C, or D, looks like that? Mostly down with 2 ups. Oh, that's works right there. No worries, Adeline. It looks like graphic B, right? Because this is, you see the 2 ups like down, 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 up, down, 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 down. And that's what we have right there when we look at it. So graphic B is the nature of the relationship. So now, if you look at this right here, it's been decreasing over time mostly decreasing over time. Now we have to write the regression equation. Make sure you know the regression equation is y hat equals b0 plus b1x. So y hat equals b0 plus b1x. Y hat equals b0 plus b1x. To solve this, you do need the regression solver, or you can do the by hand work. It's not as fun. Go ahead and copy the data to clipboard. Once you've copied to clipboard, hit Command-C or Control-C. Hit X. Go into your data sheet, click a cell, and hit Control-V to paste the data. Now, what you want to do is go here to the right and do equals, click the cell, and minus 1900. I'll pause on the screen. You can also just write 65, 75, 75, 80, 85, 90. I think I'll show it a separate way. If you start doing like 65, 70, 75, and then you click and double click, it knows to do that. You're literally just trying to make this series of numbers. The other way that I just showed a second ago is to take and subtract the 1900 by doing equals to start a formula, clicking the cell. If your equals doesn't do it, I would just write 65, 70, 75, and then if you select the cells, you can copy down. You're just trying to get it so you have these numbers. Does that make sense? As long as you get this right here, you're good to go. You can also just write the numbers over here under X. So we're just trying to get this series of numbers minus the 1900. Hit Control C and then click the top yellow cell and click Control V. Now, if the numbers don't appear and it says reference error, go to paste and paste values. That is, if you did a formula, you might lose the reference. So go to paste values. You can also right click to do that. And if this isn't working, simply go here and write 65, 70, 75 down to the bottom one. Don't go further than the last one. How are people doing? Are people all right on this? This is where people can sometimes get stuck. You just want to write these numbers right there. You could just literally write those numbers and you're good to go. So if it's not working with the copy paste, just write the numbers. Now we're going to go here to the birth rate, hold shift and click Control C, go here to the Y and hit Control V. And look at what we got. We now have the slope, the intercept, and we can also solve. So we're going to go and grab these values. Where is the assignment? The assignment is here. I think there's the intercept down to 2 decimals. And then we grab the slope. The slope is this. Make sure to not forget the negative. And the slope is that. And there we go. Is the linear regression appropriate? Mostly. We don't know if there's lurking variables. You really can't know that. Kind of a weird answer where they'd be like, there's no lurking variables. You don't really know that. You have to check for them. You have to do analysis. You have to include things. We don't know that. So I would say yes, because it follows the QQ straight enough, no outliers, plot doesn't thicken. Interpret the slope. The slope is negative 0.12. So for each additional year, because it's for each additional X, we expect the birth rate to decrease by 0.12 in hundreds of thousands of births or thousands of births on average. So it would be the slope is the number of births per 1,000 has been changing by this amount per year. So for each additional year, per year, we expect the birth rate to decrease by 0.12 thousandths. The table gives the birth rates at intervals. Estimate 1978. So what would you do here to estimate 1978? Just tell me mathematically. It's the test and it says estimate 1978. What would you do? What would you do to estimate 1978? What would you do? Who knows? For some points. To estimate for 1978, what would you do? Just plug right in here 78. That's all you do. Just plug 78 into X. It's that easy.
It doesn't matter.
Wow.
Just plug it in right there, and you're good to go. So what you can actually do, you are expected to know how to do that on the test, hence why I showed you. But you can just go down here to the bottom and type 78, and there's the answer. Regression Solver Pro. You can also check your math to make sure you plugged it in the correct way. I guess I will show that. It might come out a little bit differently. It should accept both answers. Pearson's pretty good about these, where it gives you some leeway. You just take 78 and plug it in right here to that number, 78 times 1.2, and you are going to subtract that from 25.76, and you get 16.4, which it looks like it's got a pretty big range on what it accepts, but I've checked this, and it does accept from the Pro solver and all that stuff. The actual rate was 15. So think, is the residual positive or negative? Type a plus or minus in the chat, and then I'll show you why it is this. So is the residual positive or negative? This is a good quiz question to see if you know. It is negative. Great job, Zariah. And so with that in mind, why is it negative? It's negative because when you look at this, the first question gave us the predicted, which is the line. So this was the predicted. The second question gave us the actual. So that is the y of the actual, and this is the prediction from the model. It literally says predict, or it said estimate, which means predict from the model. And this is the dot. So what is the residual? Who can tell us the residual? Don't even think about it. You can think about this conceptually. Who can tell us the conceptual residual of this? Try to conceptually figure out the residual. You get really good when you can conceptually do it. Like you can write the math, residual equals actual minus predicted. And Megan's, yes, because it's just the difference. And since it's below, it's negative. Did you do it that way? You just like, okay, what's the difference? And it's below, so it has to be negative. So you just subtract the numbers, but then you're like, and it's below the line. So, and if you want the formula right here, it's residual equals actual minus predicted. So this is negative 1.8 equals 15 minus 16.8 right there. So, and I guess we could do the color code. Well, I did yellow. So there it is. But that's the residual, negative 1.8. It's 1.8 below. So be careful. We don't have to do negative on this. The model predicts this many more births because it's above. The model's above it. It's predicting more because the actual is 15. The predicted is 16.8. The birth rate in 2020 is not yet available. More, correct. And so all you have to do over here is type in 120, and there's the prediction. And you could also take this, just round it to one decimal before even copying it. So that is under the home screen, the add or delete decimals. So you can round this before even copying it, or you can just do it when you get over here. We could have some faith. We talked about extrapolation today. This is not that far. It's 5 years into the future. That's a small extrapolation. There's some faith because this is not a big extrapolation, but now we get to extrapolating 150 years since 1900, or since the end of the data is 35 years. But this is years since 1900, and we are extrapolating past the data 35 years. So now we would put this in, the prediction, and once again, you can just plug 150 in and solve it. And there's really no faith in this because this is a big extrapolation. We should get 100. And just to confirm, if you'd entered in, I think, 0.4 here, then it would still say you're correct, even though it's only 0.4 higher now. And these questions, I guess, also probably have a good bit of leeway in them because of the way you carry decimals. So I do like this question a lot. I think it's very fair. You really, as long as you're doing the math mostly right, you'll get it right. So there's questions I like, there's questions I don't like. I like this question. It's very, very fair in how it's like, well, what if the student carried all the decimals? What if they rounded to significant digits like we asked them to? Is this, people wanted the bookstore question? This is another solve with the applet question. Are people still here? Drop another question if you want. Here's the bookstore question. It's another, the manager of the bookstore. For 250, you typed, yes, for 2050, For 2050, I typed 150. Mm-hmm. Good questions are right there. Researchers collected data. We can do that one next year. Good to see you, Kim. And bookstore one. We have done the books. Is the person who wanted the bookstore one still here? We have done it. We did in a recent video. So I might do the other one. Is my bookstore person here? Well, let's do it. We'll do it a little quickly then. So Kim will do the question next. I might do this one a little bit quickly. Here's how to do the bookstore question. To do the bookstore question, make sure you've downloaded the Regression Solver Pro. The Regression Solver Pro can be found over here under the modules. So go to your class and go to modules. And all I did was type the equations that we used to solve it and just put them in Excel and made them look nice. You'll find it under here, Regression Solver Pro. Go ahead and download the Regression Solver Pro. And then with the Regression Solver Pro, you can enter in data or you can enter in summary statistics. The top part is where you enter in the summary statistics, like the correlation, the standard deviation of y, standard deviation of x, the mean of x, the mean of y, or you enter in the data over here and it solves. These are two separate solvers, one for data, one for summary statistics. And I don't know why I did calculation error. I just like, I don't know. You can just go and delete this and see. Look at this. Look at this. You see, here's all the math I do. Okay, with that in mind, I made this years ago. We're going to go ahead and grab our data. And you can see we get summary statistics down here on the bottom, so you could enter those in, like the correlation, the mean of x, the mean of y, the standard deviation of x, standard deviation of y. I like to take the data here, go to the copy to clipboard. Now hit Control-C or Command-C to copy. Go back and click inside the cell and hit Control-V or Command-V to paste. In each question, you need to know, what are we predicting? We are predicting sales. So click the top value in sales, hold Shift, and click the bottom one. Now hit Control-C or Command-C, and since we're predicting sales, that goes in the Y variable of interest. Do not paste on the top value of Y, that'll mess it up. Now click the top value of working people, hold Shift, click the bottom one, hit Control-C or Command-C, and then paste under X. Notice we now have the intercept and the slope. Better yet, I think it might say round to 3 decimals. You can round while you're in the program itself. So let's go ahead and take these numbers. I'm just going to copy paste. It says for the slope right there, and it does say, let's see what it wants. It wants to 3 decimals, and this is the slope because it's B1. And we also have that labeled in the regression solver. You can see it says B1 right there is the slope. So you get some notation practice. Everyone knows some
Notation, brother.
So the slope is this value, and the intercept is this value right here. Nope, I knew it. That's why I said nope. And what does the slope mean? Remember, X is workers. So for each additional worker, for each additional X, we expect Y to increase or decrease by B1 on average. So for each additional worker, we expect the amount of sales to increase by 9.934 times 1,000, so $934 on average. It means that on average, total sales, an increase in this is associated with each person working. So for each additional worker, we expect sales to increase by 1,000. What does the intercept mean? Well, it's illogical because it means 0 people are working. So when X is equal to 0, we expect Y to equal B0 on average. It means that on average, the total sales will be equal to this. Yep, it should, Zariah. Multiplied by the number of salespeople work. No, that's not it right there. It means on average, the expected sales is this times 1,000 with 0 salespeople working. It doesn't make sense because if no one's working, no money. So now we put the intercept and the slope. Remember, this is B0 plus B1x, the predicted value of sales. So now it says if 20 people are working, what do we predict? And it says round to the nearest $10. So what you have to remember is this down below is in thousands of dollars. So what could you do? Equals this times 1,000. And there's the answer, not rounded to the nearest 10. Oh, well, won't let me do that. You can only round to no decimals. So we have to go back over here and plug it in. Now, on the test, you are expected to know how to solve questions like this, which means what you would do is you would take and simply plug in 20 into this problem. So all you do right here is this is number of people working, and just plug in 20. So we take 20 right here. You are expected to know how to solve these. And then you add to it 7.922, and then you times by 1,000, and you get basically the same answer, round to the nearest $10. It's kind of weird, it says that. So the actual sales are 26,000. So when you think about this, we predicted 2660, which would mean 26,600 is here, but the actual, and we'll do it in a blue, is down here. Do you still have in-person? Yep, we'll still do in-person today. Wait, let me double check, Zariah. What time is the event? Okay, no, the event. Oh, you have to leave here in like plant biotech building. I have to leave in I'll probably leave in like 10 minutes. We'll do one more maybe. Then I got to run back. Yeah, I should be doing in person. I can do it. Yep. There's an event, hence why I also kind of want to start early today too. Do some questions. Zariah, do you know what the residual is? Do you have a guess? You're welcome, Zariah. Get to see everybody. What is the residual? Well, residual is actual minus predicted. The predicted is 26,600. The actual is 2,600. The residual is their difference, and the residual is negative. So residual equals actual minus predicted. You got it, negative 600, because negative 600 is equal to the actual of 2,600 minus 26,600. Once you do residuals a few times, you're like, oh, it's below the line, it's negative. Anything below the line has to be negative. Anything above the line is positive. So that's 600 below the line. We overpredicted by 600. So the residual is negative 600, and the model overestimated it. It should get 100. Yes. It's funny, like some of the things that are like subjective are much tougher because it's like, wait. And then one more right here. We'll do one more, and then I'm going to run with plant science. And thank you. It is, wait, where were they? I saw it. It was here. Where's their question? What was it? I know there was another one. Researchers collected. Kim said it. Researchers collected. Let's go and take a look at it. Here it is. Researchers collected. Oh, we're doing some of the toughest ones. These are the tougher ones. Good ones to get done. Okay, stat 201. Researchers collected. So this is on the hardness of water of a town. What does hard water mean? It means that it has minerals in it. You see calcium buildups on the wall. Just like, what is that? Someone actually posted on Reddit recently. They were like, I left this glass of water in my drawer for a month, and look what's in it. And it's the minerals, making the water hard. So harder water has more minerals, more calcium. So this is a fairly strong negative correlation where harder water has lower mortality. So harder water tends to have lower mortality because harder is further over in the axis, mortality is dropping. The big thing for this question is knowing this output right here. In our class, there's 4 things you're responsible for from this notation. The 4 things you're responsible to know are going to be the slope, the intercept. Let's highlight them as we say it. The slope, the intercept, the significance of the model, and the r squared, which has already been turned to a percentage. So we have the values right here of B1, B0. You see it says coefficient, that means number for the x variable. Coefficient, the other one says coefficient of the intercept, means value of the intercept. This is the statistical significance, and this is the r squared up there. So let's go ahead and drop these numbers in because this is y hat equals b0 plus b1x. We're just going to drop b1 and b0 in there, and we'll have written the regression equation. So b0 to 3 decimals, they've already done it. And this one, make sure to do the negative. If you don't do the negative, you lose points. There we go. What does the slope mean? It means for each additional bit of calcium. Oh, you're welcome. You're welcome, Megan. For each additional bit of calcium, we expect the mortality rate to decrease by 3.69 that's the slope, right, on average. So for each additional thing in calcium, the model predicts the mortality to decrease by this on average. What does the intercept mean? It means if there's no calcium in the water, 0 calcium. When x is equal to 0, y equal b0 on average. The model predicts a town with 0 parts per million calcium, because all you do is plug in 0 right there, would have a mortality rate of 1,723. The largest residual is 85.8. What does this mean? Well, if the residual is positive, then it has to be above the model. So a positive residual, we draw the line right down like that. A positive residual would be, like this point right here might be the largest residual. That means it's 85.8 higher than the model predicts. 85.8 higher than the model predicts. So the town had this many more per 100,000. Make sure to do the 100,000. It'll mean that they throw that in here on this one. But there you go. The hardness of a certain town water is 172. Make a prediction of the deaths per 100,000. So what do? All we do is go back here and plug in 172. This is just making a prediction from the model. So we just say, okay, we're going to plug in 172 and just drop in the number. So 172 times 3.69. And then we take this and go 1723.203 minus that number. So just solve the equation by plugging in 172. And then we've got the answer. I've clicked on that before and lost it. 3 decimals, really? Really? And then last but not least, r squared is the percent of variation in y explained by the variation in x. So 92.9% of the variability in mortality can be explained by the variability in calcium. Yay! We've done it. We did this. We've done a lot of these. So I will say if you're stuck on any of these, we've done those. Oh, that's a good residual plot. So that doesn't have, this is a good residual plot. That one is predicted power getting worse. So the predicted power decreases. That's a nonlinear model. Yay! Another one. That's a fan pattern predicted power getting decreasing. That's everything good except for 1 point. And then that's another curved pattern right there. Bad residual plot. Yeah. Correlation between this. What is the r squared percent of variability? So 0.909. There it is, times by 100. Oh no! I copied it. And then to the nearest tenth. that one. What is this? What does the slope mean for each additional unit of displacement, which is like a ratio or something? We expect the combined miles per gallon to decrease by this on average. The model estimates that the car loses for engine size. The model estimates that the car loses an average of 3.316 liters. Nope. We lose miles per gallon. There we go. Because we're predicting miles per gallon. You're welcome, Kim. Hopefully you got that. Look at me. Look at me going too fast. No, for each additional displacement. Wait, is this a slope? I was like, for each additional X, we expect Y to increase or decrease by V1 on average. Good job, Megan, right there. I threw some 5,000 points. I was like, I haven't eaten lunch yet. Still got my sandwich. It's okay. Thank you. Oh, what is this right here? We've done a lot of these. So now we've done a lot. Explain what the slope means for each additional thing of fiber. The model predicts an increase of potassium of 24. The model predicts that cereals will have approximately 24 more grams of potassium for additional gram fiber. There it is right there, for each additional gram fiber. And we'll do just a few more. I'm going to run across campus. For this model, you can estimate a cereal's potassium in the context. What does it mean to say a cereal has negative residual? Negative residual means it has more potassium than predicted, or its actual is lower. So the potassium content is lower than the model predicted. If it's negative, it's below the model. So its actual is lower than predicted. And just make a prediction for a 5-liter car. Cool. 5-liter car. I'm speedrunning the whole assignment. I feel bad if I don't do, really. That's not what I wanted. 5 times 3.892. If I just learned how to write numbers in a calculator, I would ace all of these. Well, it wasn't even that. There we go. And round to the nearest 1 decimal. Predict for 8. Okay, wait, we should do this in our head. 240, 214, 214, 251. I think it's 251. Really? Okay, let me redo it in my head. No, 216. So I dropped a number. There we go. Once again, just plug in the numbers. Plug in 8 times. This is where I made the math error. It should be 226. I reversed my 4s and 6s when subtracting. So it should be 216. Now I'm saying the wrong numbers. But there we go. I should have been faster on 8 times 27. Come on, Brian. It's fun doing it in your head. See if you get it right. One question. 12% of the variation of students' GPAs can be accounted for on a linear model on their work hours. That sounds right. So 12.7% of the variation in GPA can be explained by the variation in working hours. And what is the value of R squared? Does it give it? We got to find the value of R squared. Go to the regression solver. How do you know which one is the Y? Some of them will do that for you. Hopefully, it might say we want to predict. They should say, here it is right here. GPA is the response. That's a good question, Megan. The question should say things like GPA is the response. We might end on this one, but we just did. We've done a lot of them now. But GPA being the response means Y variable of interest. The response variable is the Y variable. Good work, Megan. Let me see. I need to run over to the... You're welcome. No, thank you for asking that. I'm glad people are chilling out. The event I'm going to... That's after spring break. I am going to Plant Biotech Building. Where's Plant Biotech Building? 156. Okay. Plant Biotech. What should be like off campus? All right. Where is this? Why is it not loading? Oh. Okay. Oh, I need to go to the ag campus. Oh, it's there. Okay. Well, with that, bye for now, everyone. Bye.